So let's review a few properties of logarithms. Some of these we mentioned before, but I want to really emphasize some of the key properties that we get out of logarithms here. So the first one is log base b of m times n. Right? If we have the product inside of a logarithm, this becomes the sum of the individual logarithms. It's a pretty interesting property here that we get. But this is going to turn out to allow a lot of simplifications. Likewise, if we have a quotient inside of the logarithm, this is log base b of m minus log base b of n. Right? So again, it's some pretty interesting things here that we get. All right. Another property, and this is something quite important here, is that log base b of b is 1. Right? So if we plug in the same number that's the base of the logarithm, we get 1. Right? Let me also emphasize all of these properties work for ln as well. And the reason I want to emphasize that is because this one, might look a little funky. Remember that log base e is ln. So this one tells us that ln of e equals 1. Okay? Building on that, log base b of b to the x is x. We've talked about this one already. But just a reminder that the corresponding property for ln is that ln of e to the x equals x. This is something you're going to use a lot. Okay. Another important thing is, what if we do log base b of 1? Well, that's 0, because b to the 0 power equals 1. All right, and this would be true for ln as well. ln of 1 equals 0. All right, number 6. b to the ln, or sorry, not ln, b to the log base b of x is x. All right, we've talked about that one before as well, and for ln it looks like e to the ln x equals x. All right, and the very last thing is arguably the most important property of logarithms. We used this when we computed derivatives of exponential functions. All right, and we're going to use this a lot. Okay, here we want, if we have log base b of m to the r, okay, we have that. What we're allowed to do with logarithms, and we've talked about this before, this r here we can pull out. R log base b of m. Okay? And again, that works for ln as well. If you replace log base b with ln, this still works. All right, so there's quite important properties here for logarithms that we'll use. So now that we've kind of talked about logarithm and its properties, I want to go on to the next step here, because we've talked about various functions, polynomials and algebraic functions. Now that we've done the product, quotient, and chain rules, we know how to differentiate any of them. We've talked about derivatives of trig functions. We've talked about derivatives of exponential functions. This one here, the logarithm, we now need to talk about the derivative of that. Okay. So let's focus first on ln. So question: what is the derivative of ln of x? All right, so how do we do this? Well, we don't really know how to compute this derivative, right? We don't know much about it. But given what the logarithm is, we can sort of undo it. Or we can sort of rewrite it and see if that helps. Okay? So, y equals ln x, right? We can use the properties of logarithms to say, well, this means e to the y equals x, right? Okay, so now what we're going to do is take the derivative of this, of both sides of the equation here. All right, so we take the derivative of both sides, so we get this equation. On the right side here, this is just 1. What's going on over here, though? How do we differentiate this? All right. So I want you to think about this in sort of a special way here. Let me just call this f of x. Okay, ignore the fact that it's ln up there. And instead of y, let's think of this as e to the f of x. Okay. Well, we can use the chain rule now to differentiate this, right? We know how that works. So, if we use the chain rule on the left side here, we'd get the derivative, the outside function is e to the x, the inside is f of x. So we get the derivative of the outside times the derivative of the inside equals 1. All right. Now I'm going to replace... Actually, you know, we'll leave the f here for now. All right, let's solve for this thing. Right, we're really interested in this guy. Actually, all right. Actually, I lied. Let's switch this back for y. This says e to the y times dy dx equals 1. Solve for dy dx, right? And this gives us dy dx equals 1 over e to the y. But we know y is equal to ln x. So dy dx is 1 over e to the ln of x. But what happens here on the bottom with e and ln? We know that they cancel each other out, right? So this is just 1 over x. So what have we shown? We've shown that the derivative of ln of x is in fact just 1 over x. All right? So, one more property of logarithms here that we call the change of base formula. Right? And we can really do this with any types of logarithms, but ln is the most important one. So log base b of x, we can actually write this as ln of x over ln of b. Okay? Now this might not be obvious to you, and I don't blame you at all. And I would suggest, you know, if you're interested in why that's true, go look it up. But using this, we can answer the question, well, what is the derivative of the more general logarithm? Right? Well, this is d dx of ln x over ln of b. And I want to emphasize, ln of b is just a constant, so we can factor that out. Oops. Times the derivative of ln of x. So, and we know the derivative of ln x is 1 over x. So there's our derivative. So we'd usually, you know, write this a bit neater. Log base b of x is 1 over x ln b. We'd usually write it in this way. All right. So hopefully that makes sense. We got some nice properties of logarithms, and we now know the derivatives of logarithms. All right. Now, before I end this video, the reason we did this now is this process that we did right here, okay, for finding the derivative of ln of x. This is a very important process. This is something that we call implicit differentiation. So we'll study this a bit more in the next video or so. And yeah, otherwise, I hope this all made sense. And I'll see you for the next one.